Today we're going to take a look at the unit circle. The unit circle is really kind of a shorthand way of doing Pythagorean's theorem. It's some of our more popular angles. And instead of creating triangles and doing Pythagorean's theorem, what we can do is familiarize ourselves with the unit circle. So I'm going to give you a sheet here in which you'll fill out. You'll take a look at this as I talk and start filling these things out as we go. A couple of things you want to recognize right off the bat is the coordinates for the unit circle. The cosine values are always going to be in the x coordinate, and the sine values are going to be the y coordinate. And then write this down where you can. The tangent of an angle is always equal to the y value divided by the x, or in this case, since the y value is sine and the cos value is x, we can say that tangent is sine divided by cosine. So we're going to look at this thing one quadrant at a time. I've also put together in pink, you can see where I've marked some of these things. These are the values of tangent. You might need to write the values of tangent in for yourself. I think it's worth recognizing those and having those handy. So let's just take a look at the first quadrant here and talk about what exactly we're looking at. So on the unit circle, first of all, one of the key things that the unit circle provides for us is an easy conversion from degrees to radians. So 30 degrees is equal to pi over 6 radians. 45 degrees is pi over 4. 60 degrees is pi over 3. And then 90 degrees is a half pi radian measurement. So we can immediately look and see what these values are. So what we will do is, instead of creating, what happens on these unit circles is we create a 30, 60, 90 triangle. And we won't do this on every one, but this is what we'll take a look at. And everything on the unit circle is a 1 radius. So this side over here has a radius of 1. So if we're talking about a radius of 1 on a 30, 60, 90 triangle, the radius is the hypotenuse, and the hypotenuse is always twice of the small side. So the small side would be 1/2. Which, of course, if we look on the coordinate planes, how far we go up is the y value. And as we said at the beginning, the y value is the sine value. And if the small side is 1/2, been a while probably since you've done this, but the difference between the small side, to go from the small side of a 30/60 to the medium, we have to multiply times the square root of 3. So if we have a small side of 1/2 times the square root of 3, that equals our value that we see in the cosine, which is the square root of 3 over 2. So as I said, this is just really a shortcut way of recognizing all of these things about the 30, 60, 90 triangles. So raise some stuff I didn't really want to, but that's okay. The next one, we could see 60 degrees, and really it's the same concept. Because if this degree is 90, we would drop another one that is 30, and we would have again another 30, 60, 90 triangle, and this 30, 60, 90 triangle will have the same proportions, except for they would be reversed. And if you'll pay attention, you can see that the cosine, square root of 3 over 2, is the sine value for the 60 degree angle. And at the same time, the sine value of 1/2 is the cosine value of the 60 degree angle. So all of these ratios of all of these values, 30s and 60s, are going to have the same combination of 1/2 and the square root of 3 over 2. So when we look in the second quadrant, you can see same thing. except for all of our x values are going to be negative and all our y values are going to stay positive. Just think about what we have. We have a coordinate planes. On the left side of coordinate planes, the x's are negative and the y's above are positive. So we can see this pattern just keeps happening over and over again. As we look in the second quadrant, same pattern. As we look in the third quadrant, again, same pattern. There's the square root of 3, negative square root of 3, negative 1/2. And we have negative 1/2, negative square root of 3 over 2. And again, the signs are both negative because in the third quadrant, both the x's and the y's are negative. And in the fourth quadrant, the x's are now positive because they're on the right side, and the y values are negative. But again, here they are. Square root of 3 over 2, and 1/2, and 1/2, and the square root of 3 over 2. Because these are all versions of a 30, 60, 90 triangle. So you can see that we skipped the other part, which is the 45-degree angle. Well, the 45-degree angle, when we create the 45-degree angle, what we've essentially created is a 45, 45, 90 triangle. And radiuses never change, so that keeps the radius of 1. And remember, the way we move from small side to the large side of a 45, 45, 90 is we multiply times the square root of 2. So the way we move back is we divide by the square root of 2. So 1 divided by the square root of 2 is the square root of 2 over 2. And since the x and the y values are always the same on an isosceles triangle, both sides are going to be the square root of 2 over 2. So we can see that's what's happening here. Square root of 2 over 2. And as we move to our quadrants, other quadrants, you see the angle that's in the middle, the 45-degree angle in the second quadrant, same coordinates, except the x value is negative, the y value is positive. As we move to the third quadrant, since the x and the y are both negative in the third quadrant, that's what we have. And in the fourth quadrant, the x is going to be positive and the y is going to be negative. But you can see the pattern that is developing here. And then lastly, we have the 90s, 180s, and the 360s. But if you think about this, these are not forming triangles. We have to have 3 sides to a triangle. So when I construct this value here, when I construct this line that we're looking at here, it is just a line, it's not a triangle. But the radius of this circle is still 1, so we've moved over 1 and up 0. So the cosine of 0 degrees and 360, the cosine is 1 and the sine is 0. As we go to the 90-degree angle, again, the radius is still 1. So the ordered pair is left 0, up 1. So our cosine is 0 and our sine is 1 on a 90-degree angle. 180, our cosine is negative 1 and our sine is 0. And then our 270, we've moved none left and right, so our cosine is 0 and our sine value is negative 1. So those are all of our relationships. I have a diagram for you with all of this information, so if you didn't get this in time, get those copied down. So the sine ratios are created by dividing the sine by the cosine. So we won't look at all of these. What we will look is at the 30-degree angle measurement. So you can see I've already given you the answer. The answer for cosine is the square root of 3 over 3. Let's see why it's that. Well, the way we do this is we do the sine value, that is 1/2, divided by the cosine value, which is the square root of 3 over 2. Now, we don't want to divide fractions, so instead what I'm going to do is multiply 1/2 times the square root of 3, multiply times 2 over the square root of 3. So the 2's are going to cancel, and what we end up with is 1 over the square root of 3. Well, that's not what we see over here. Well, that's because this is not written in an appropriate form. Remember when we talked about radicals, I have a little method I call bump and keep. So I'm going to bump the square root of 3 to the top and keep the denominator as the radicand. So I've given you the tangent ratios throughout this value because you don't see these often for one, but do you really want to divide every time you're asked to find tangent? So we can use our values here and do that. Want to highlight one last thing before we move to the next slide, and that is the fact that the tangent is 0 at the 0 and the 180, because 0 divided by 1 is 0, and the tangent for 90 degrees is undefined, and 270. Because you can't divide 1 by 0. All right, so that was a bit of a long explanation. Hopefully you've had the time to fill out your unit circle so that you can have this. If you haven't, again, I've posted that. We're going to move on and see how we can use, and the part in the middle is just the decimal values in case you run into these trig decimal values. Trig and 45, 45, and 30, 60, 90. All right, so like I said, we're going to move on and see how we use this. So here's how we use the unit circle to help us get through these quickly. The main thing you need to recognize is the cosine values are our x values and the sine values are our y values. So when I'm asked to find the cosine of 225, what I'm basically being asked is, what is the x value at the angle 225? So I'm going to go locate the angle 225. The angle 225 is right here. And like we said, the cosine is the x value. So the x value where we are looking here is the negative square root of 2 divided by 2. And that's all there is. So x would equal the negative square root of 2 over 2. So the next example, we're looking for the sine of 315. Sine of 315, well, the sine is in fact the y value. So let's first find 315. There it is. 315 is negative 7/4 pi. And it's asking me for the sine value. So the sine value of this is going to be the y value. So this is also the square root of negative 2 over 2. And here's where we're going to get a chance to use the tangent. You can see my stuff is off the screen here. If you have yours written down, well, then all you've got to do is reference that number. But I don't have the luxury here. So what I'm looking for is the tan of 5 pi over 6. Well, 5 pi over 6 is right here. It's 150 degrees, and this is our ordered pair. So the way we have to do this, if we don't have the unit circle marked for tan, is again going to take the y value, 1/2, divided by the x value, which is negative 3/2, negative square root of 3 over 2. But I never divide fractions. So what I'm going to do instead is multiply times the reciprocal. So instead of 1/2 divided by, we're going to do 1/2 times 2 over square root 3, and that is a negative sign. Again, the 2's cancel, leaving me with 1 times negative 1 is negative 1 over the square root of 3. and I'm going to bump the square root of 3 to the top and keep the denominator of 3. So that's how we get the tangent ratios on our figure. And again, I don't see many unit circles that they do give you the tangent, so I do that. So hopefully you're taking advantage. All right, and the last one, nothing tricky here. It's just written in radian form. So we're looking for the radian of 4/3 pi. So as I looked over my segment here, well, there's 4/3. It's 240 degrees. And we are looking for the sine value. Well, the sine value is the y value. So the y value at that point is -3/2 over 2. So this is how we use our unit circle. And the unit circle is a circle with a radius of 1. That's why we get these weird fractions, is because our radius is always 1. So what we're going to do here is just a little repetition. It's really the same concept. We're just going to do a little repetition. So when I say sine of 60, essentially what I'm asking you is, what is the y value at 60 degrees? Well, here's 60 degrees. Our y value is going to be the square root of 3 over 2. Tangent of 45. Again, if you have your tangents, well, there's 45. Tangent is y divided by x. Well, you're going to be dividing by the same amount here. So square root of 2 divided by the square root of 2 is square root of 2 divided by 2 divided by the square root of 2 divided by itself, let's just say that, is 1. Tangent of 45 is 1. Cosine of 45 degrees. So the cosine, we're already at 45 degrees. Cosine is the x value, so it's the square root of 2 over 2. And then the cos of 60 degrees. Well, we've got the 60 degrees already marked for sine, which is the y value. So now we just need to identify the cosine, which is 1/2. And then, like I said, what we can do is use the unit circle to also convert our values. So instead of multiplying this times pi over 180, which will work, by the way, instead of doing that, if we know it's on the unit circle, all we've got to do is find it. So 20 degrees correlates with 2 square root of 3, 2 pi over 3, excuse me. So that would be the conversion. 180, well, 180 is just simply pi. 225, there they are, 5 pi over 4. And then lastly, -30. Well, 30 is pi over 6, so -30 is going to be -pi over 6. So the unit circle is also a very nice way to convert degrees to radians. The limitations, of course, there's a lot of angles, infinite number of angles, really, when you start talking about decimals, but we are only looking at a very select few. Now, it's the most popular few, but it is not all angles. And the last thing we're going to take a look at today is the inverse trigs. So essentially, this is the complete opposite of what we were doing. We were finding the angle and putting out the coordinate that correlated with that. Well, this is doing the opposite. Basically, we're saying, hey, we're going backwards here. We're going inverse cos. So what we're saying is, what angles have an x value of the square root of 3 over 2? Well, let's highlight some square root of 3 over 2's. And again, it's cosine, which means we're looking for x values. Before you get too anxious on these, well, look, I found my x value. So my answer is 30 degrees. But I want everybody to look. I'm going to give you 5 or 6 seconds here. Can anybody see another issue? So what I've basically said is cosine. The angle that has an x value of the square root of 3 over 2, that angle is 30 degrees. That is not an incorrect answer, but it's also not a complete answer. Have you identified what I'm trying to say? Hopefully what you notice is if you drop straight down there, the angle 330 also has this value. So there are actually two answers to this: 30 degrees and 330 degrees. Now let's take a look at sine. This is an inverse sine. So essentially what they're asking me is y value. Which angle gives us a y value of square root of 2 over 2? Well, let's find the square root of 2, negative square root of 2 over 2, by the way. So the y values. Y values that are negative, of course, are in the lower quadrant down here. So we're not even going to look at the top. So the y value of negative square root, well, this one has it. And so does this one. So this actually is not completely correct, but I want to practice this. Since the S is capitalized on this one, it actually means a reference angle. I mean, restricted angles. But we're not having to worry about those, so we're just going to name them all. That should be a lowercase s, though. So the angles that have a y value at negative square root of 3, or negative square root of 2 over negative square root of 2 over 2 is the angle 315 degrees and the angle 225 degrees. And then the last thing, cosine, the x value. What we're essentially looking for is an x value, because that's what cos is, x value of 0. There's an x value of 0. There's an x value of 0. So our degree measurements are going to be 90 degrees or 270 degrees. And what we kind of ignored is the fact that this is actually 2, because this could be 90 degrees or pi over 2. Because don't forget, we measure in radians or degrees. And the other one would be 3 pi over 2, excuse me. All right, so this is how we use our unit circle. We can use the tangents to kind of shorten things up for us. The inverse trigs are just basically saying find the angle that matches the coordinate, as opposed to the whole front side where we were finding the coordinate that went with the angle. All right, I've created a Mastery Connect for you on those. Some of these may be a little trickier, please. You can ask. This is a homework assignment. This is not necessarily a like we normally do. So if you have any questions, please ask. Good luck.